Let us continue the same lesson. Last session we had seen about the electronic configuration of atom, and I have discussed about the electronic configuration of sodium. Sodium contains 11 electrons, so its electronic configuration of 281. The outermost shell of an atom cannot hold more than 8 electrons, even it has the capacity of accommodating more electrons. Because to attain the stability, outermost electron must possess only 8 electrons. So even it has more space, it cannot accommodate more electrons than 8. Now let us see the geometric representation of atomic structure. For writing the geometric representation, we need atomic number and mass number. Let us consider oxygen. Its atomic number is 8 and its mass number is 16. Already I told the mass number is nothing but, the atomic number is nothing but, the subscript is nothing but atomic number, and the superscript denotes the mass number. Mass number is denoted by the letter A and the atomic number is denoted by the letter Z. Now, how to write the geometric representation of atomic structure of oxygen atom? We have the two datas, mass number and atomic number. By using the two datas, how to find out the subatomic particles of oxygen atom? We know that the atomic number is nothing but atomic number Z is nothing but number of electrons or number of protons, because both are equal in number. For a neutral atom, for the electrically neutral atom, number of electrons and number of protons are the same. Therefore, the atomic number is nothing but number of protons or number of electrons. So, how many electrons are there in oxygen atom means number of electrons possessed by the oxygen atom. 8. If the number of electrons are 8 means the number of protons also the same. Therefore, the number of protons in oxygen atom is 8. And how to find out the number of neutrons? Number of neutron, how to find out the number of neutrons means by deducting the number of protons from the mass number. So, mass number minus number of protons. What is the mass number of oxygen? 16. What is the how many protons are there in oxygen atom? 8. Therefore, number of neutrons in oxygen atom is 8. Now we have all the three datas, number of electrons, number of protons and the number of neutrons. By having all these three, we can write the geometric representation of oxygen atom. How to write? First we have to fill the nucleus. What are the particles present in the nucleus? Yeah, proton and neutron. How many protons are there? 8 protons. How many neutrons are there? 8 neutrons. Therefore, 8 proton and 8 neutron. That will be occupying the center part of the atom, that is nucleus. And how many electrons are there? 8 electrons. First we will draw the first orbit, that is k orbit. And then how many electrons in oxygen atom? 8 electron. What is the electronic configuration? The electronic configuration of oxygen is oxygen atom. electronic configuration of oxygen atom is 2,6. That means the first shell can accommodate 2 electrons and the second shell can accommodate 8 electrons. Therefore, first shell K shell can accommodate only 2 electrons, and then the next shell is L shell. The 6 electron will be accommodated by the L shell. So this is the geometric representation of oxygen atom. This is the method of writing the geometric representation of atomic structure of oxygen atom. Like that we can write the atomic geometric representation of other elements also by knowing the mass number and the atomic number. For drawing the geometric representation, we need 2 factors, mass number and atomic number. By using the 2 data, we can find out the number of electrons, number of protons and number of neutrons. By collecting all the 3 data, we can draw the geometric representation of atomic structure of any of the elements. Now, let us see, one more important thing I want to tell you. Atom is the tiny particle. So, that is the smallest particle of the element. So, its mass cannot be expressed in gram. So, then what unit should be used for denoting the mass of the atom? Atomic mass unit. And the size of the atom cannot be expressed in meter because that is very, very small in size. So, the size of the atom can be expressed in nanometer. Nanometer is nothing but 10 to the power minus 9 meter. And already we had seen that the atom is invisible. But nowadays it is possible by using SEM. SEM means scanning electron microscope. By using the SEM, we can view the structure of the atom. Nowadays it is possible. Next we will see the topic valence electron. What is the electronic configuration of oxygen? 2, electronic configuration of oxygen is 2,6. So, while we are drawing the structure of oxygen atom, first shell is K shell, first nucleus possesses 8 proton and 8 neutron, and then the first shell can accommodate to 2 electrons, and then the second shell, that means L shell, can accommodate 6 electrons. So, while we are drawing the geometric representation of oxygen atom, L shell is the outermost shell. This is the inner shell. The shell which is nearest to the nucleus or the inner shell. The shell which is present at the last is called the outermost shell. Here in oxygen, the outermost shell is the L shell that contains 6 electrons. So, the electrons which are present in the outermost shell are called valence electron. So, the number of valence electron in oxygen atom is 6. Number of valence electron in oxygen atom is 6. The number of valence electron will be the deciding factor of the chemical property. The chemical property of the element can be decided by the number of valence electron possessed by the atom. Since it contains 6 electrons, its chemical property is decided by these 6 electrons. The elements which contains the same number of valence electron will be showing the similar property. For example, let us consider any of the element X that also contain valence electron, last shell electron 6, and oxygen also getting the last shell electron 6. So the valence electron are the same for the element X and for the element oxygen. So the valence electron are the same. Both are getting the same number of valence electron in its outermost orbit. So the elements which contains the same number of valence electron in its outermost orbit will be getting the same chemical property. So these two elements will be getting the same chemical property. And then for the metals, the valence electron, that means the number of electrons possessed by the last shell for the metals. The number of electrons, valence electron is how much, means 1, 2, 3. For the non-metals, one, 2, 3, sometimes 4 also, and then for the non-metals 4, 5, 6, 7. Next we are going to see valency. Valency means combining capacity. How many hydrogen atoms can be combined with the particular element, that also decided by, that also valency. And how many electrons can be lost or gained, how many electrons lost or gained by the atom, that also valency. Number of electrons lost. Lost or gained by the atom. That is also we can say that valency. So combining capacity, number of electrons lost or gained by the atom, that also valency. For example, metals getting 1 electron, 2 electron or 3 electron, 1 electron or 2 electron or 3 electron in its outermost orbit. So they are capable of losing, for attaining the stability, they are capable of losing 1 electron, 2 electron or 3 electron from its outermost orbit. For the case of non-metals, it is not possible to lose 4 electron, 5 electron, 6 electron and 7 electron. So what they will do means, they will be gaining, for making this as 8, they will be gaining 4 electron. 4 electron it is not possible, gaining 4 electron is not possible. For the case of valency 4, they will be sharing the electron, 4 of its valence electron with some other elements. 4 electrons will be shared. In the case of 5, 6, 7, what they will be doing means, they will be gaining 3 electrons. This element will be gaining 3 electrons from some other element, and this element will be gaining 2 electrons from some other element, and this element will be gaining 1 electron from some other element. So for the elements which contains the valence electron 5, 6, 7, they will be getting the capacity of gaining 3 electron, 2 electron and 1 electron from some other element. So that is the valency of non-metals. For the case of metals, for making the outermost electron 8, they will be readily losing 1 electron or 2 electron or 3 electron from its valence shell. So the valency of metal is 1 or 2 or 3. Some elements will be showing variable valency. What is the reason for showing the variable valency means? The outermost shell is called the ultimate shell, otherwise called the ultimate shell also. And the shell before the ultimate shell is called the penultimate shell. Usually the number of electrons gained or lost by the outermost shell. Sometimes for attaining the stability, penultimate electrons also jumps from its energy level to the higher energy level to attain the stability. So in that case, some elements will be showing variable valency. For example, iron is getting 2 kinds of valency, Fe2 plus and Fe3 plus. So iron is getting 2 kinds of valency, 2, 3. For the case of 2, the outermost shell will be losing 2 electron. For the case of 3, the outermost shell will be losing 2 electrons. With that, the innermost, the penultimate cell also will be losing one of its electron to attain stability. Therefore, they are getting variable valency. And then the tabular column is given in your book in the page number 130. By seeing that, you can understand the electronic configuration of elements and how to distinguish metals and non-metals. If the valence electron is 1, 2, 3 means they are called metals. If the valence electron is 4, 5, 6, 7 means that is called non-metal. It is given in your book at the page number 130. And some of the elements will be, naturally they will be getting 8 electron in its outermost orbit. For example, in the case of neon, neon is getting the electronic atomic number 10. So, what is the electronic configuration of neon means 2, 8. So, it is getting 8 electron in its outermost orbit. For attaining the stability, the outermost shell must possess 8 electron in its outermost orbit. Already it is getting 8 electron in its outermost orbit. No other extra electrons are there in some other orbits. So, it neither it can gain or nor lose it from its outermost orbit. So, neon is getting, already it is getting 8 electron in its outermost orbit. Already it is stable. So, it need not to gain or lose. So, its valence is 0. The elements getting the 0 valence is called rare gases or noble gases. And then, how to find out the valence of magnesium? Valence of magnesium, we know that the atomic number of magnesium is 12. So, what is its electronic configuration? Electronic configuration of magnesium is 2, 8, 2. Therefore, the outermost shell contains 2 electrons. So, what is the valence of magnesium means? Valence of magnesium is 2. And in your book, the page number 131, how to write the geometric representation of atomic structure of elements is given. In that, magnesium, what is the electronic configuration of magnesium? 2, 8, 2. And then for the case of calcium, the electronic configuration of calcium is 2, 8, 8, 2. So, both are getting the same number of electron in its outermost orbit. So, valence of magnesium also 2 and valence of calcium also 2. And then next we are going to see isotopes. Look at these two atoms. This also chlorine, this also chlorine. So, these are the atoms of the same element. This also chlorine atom, this also chlorine atom. Already I told atomic number will be the same for the atoms of the same element. So, the atomic number of chlorine is 17, for this chlorine also 17, because both are the atoms of the same element. Atomic number won't be different for the atoms of the same element, but mass number may be different. For this, the mass number is 35, for this the mass number is 37. So, atoms of the same element getting the same atomic number, but they have different mass number. What is the reason for difference in mass number? Means because of the number of neutrons. Already I told, for electrically neutral atom, the number of protons and the number of electrons will be the same. For the electrically neutral atom, the number of electrons and number of protons will be the same. I told. Therefore, first isotope, chlorine 1735, is getting the number of electrons 7 and the number of protons also, number of electrons is 17 and number of protons also 17. For the case of chlorine 1737, the number of electrons also 17 and the number of protons also 17. In which way they are differ from each other? Means in total number of neutrons. For example, first case, let us see the first case, chlorine 1735, atomic number is denoted by A and the mass number is denoted by Z. A, this is Z. What is the number of electrons? Number of electrons possessed by the first case, that is 17. If the number of electrons are 17, means the number of protons also 17. But how to find out the number of neutrons? Number of neutrons is equal to mass number minus atomic number. Therefore, 35 minus 17, that is 18. So, the number of neutrons possessed by the first case is 18. Let us see the second case. That means chlorine 1737. Already I told the atomic number denotes the number of protons. So, number of protons possessed by the second case is 17. If the number of protons are 17, means the number of electrons also 17, because this is positively charged, electrons are negatively charged, both are equal in number for the electrically neutral atom. Therefore, number of electrons possessed by the second case also 17. Then how to find out the number of neutrons? Mass number minus atomic number. Therefore, 37 minus 17, it is getting 20. Here, for the in the first case, the number of neutron is 18. In the second case, the number of neutron is 20. So, in which way they are differ from each other? The number of neutrons. Number of protons possessed by the first case and second case also the same, and the number of electrons possessed by the first case and second case also the same, but the number of neutrons possessed by the first case is 18 and the second case is 20. So, in which way they are differ from each other? Means in number of neutrons. So, how to define the isotope? Means isotopes are the atoms of the same element. Isotopes are the atoms of the same element having the same atomic number but different mass number. The difference in mass number is because of difference in number of neutrons. Difference in number of neutrons. Next we are going to see isobars. Let us consider calcium 2040 and then argon 1840. Look at these two. Are they atoms of the same element? No. This is calcium atom, this is argon. So, these are the atoms of different element. Already I told atoms of different element will not be getting the same number of definitely will not get the same number of electrons. So here the number of electrons or number of protons possessed by calcium is 20. That means atomic number is 20 and the atomic number of argon is 18. So they are differ in atomic number because atom of different elements will be getting different atomic number. So atomic number of calcium is 20, atomic number of argon is 18. And look at the mass number. Mass number is the same. What is so how to define isobar? Isobars are the atoms of different elements. Atoms of different elements. This is calcium atom, this is argon atom. So atoms of different element having the same mass number but different atomic number. In which way they are differ? Different atomic number same mass number. So atoms of the different elements. Isobars are the atoms of the different element having different atomic number but have the same mass number. So that is called isobars. Next we will see isotones. Look at these two elements. This is boron atom, this is carbon atom. So these are the atoms of different elements. Look at the atomic number. Since they are different elements, atoms of the different element, definitely they will be possessing different atomic number. So the atomic number of boron is 5, the atomic number of carbon is 6. Look at the mass number. Mass number also different. So in which way they will be getting the similarity? Let us see. So they are getting the different mass number and different atomic number. In which way they will coincide with each other means they will be similar each other means. Look at the number of neutrons possessed by boron atom. For finding the number of neutrons, what is the formula? Mass number minus atomic number. The mass number of boron is 11 and the atomic number of boron is 5. Therefore, 11 minus 5, 6 neutrons. This is for the case of boron. And the number of 12 minus 6, we are getting 6. So look at the number of neutrons. So atoms of the different element having different atomic number, different mass number, but they are getting the same number of neutrons. So the atoms of different element having the same number of neutrons are called isotones. So let us summarize the things that we had seen in this session. Isotope. And then isobar. And then isotone. what is isotope means? Atoms of the same element having the same atomic number but different mass number are called the isotopes. What is isobar means? Atoms of different element having the different atomic number but having the same mass number are called the isobars. And then what is isotone means? Isotones are the atoms of different elements having different atomic number, different mass number, but the number of neutrons are the same. That is called isotones. And we can classify the isotopes into two types. Unstable isotope. Isotopes are classified into two types. First one is unstable isotope and then stable isotope. If the number of neutrons are as that of proton means, that is called a stable isotope. If the number of neutrons are excess, then the number of protons means, that is called the unstable isotopes. The number of neutrons are excess, that is called unstable. If the number of neutrons are excess in number means they will be emitting the radiations. So they will be getting the radioactive property. So unstable isotopes are called radioisotopes. Why they are called radioisotopes means because of the excess number of neutrons. The excess number of neutrons stimulate the atom to emit radiations. What kind of radiations will be emitted means alpha rays and then beta rays and gamma rays will be emitted because of the excess number of neutrons. So they are called unstable. They will be changing their structure often, so they are unstable. Since they are getting the property of a radioactivity, that means emitting the radiations from their atom, and stable isotopes will be getting the stable structure. And then it is widely used in medicine and other field also, radioisotopes, that we will see later. முடிச்சதுங்களா? Let us recollect the things which I taught in this class. What are the topics we have discussed in this class means, first one, geometric representation of atomic structure. And then valence electron, and then valency, and then isotopes, isobars, isotones. These are the topics we have discussed in this class. With this, I'll be winding up this session. We will see later.